Hi, my name is Andrew Betts. I work for Fastly. I am going to talk to you about HTTP headers. So, for a little bit of context and a little bit of history, HTTP 1.1 was standardized, if I turn my clicker on, in 1997, and a typical HTTP exchange looked like this. I think we can all understand this. This makes sense, right? We have a request line. We have a host header. The host header was introduced in HTTP 1.1 and introduced for the first time the ability to have multiple websites on the same IP address or on the same web server. And in the response, we have the date stamp when the response was generated. We have something that tells us what kind of data we're going to receive, and we have something that tells us how much data we're going to receive. This is great. This is what that request-response cycle looks like today. So, we have some work to do to try and understand this and to work out, is this best practice? Which of these headers should we be using? Which ones have kind of fallen out of favor and we should be using less? I'm interested in this for a few reasons. I used to be an elected member of the W3C's technical architecture group. This is a group of 9 people that review web standards, proposals for additions to the web platform. And I noticed that quite a few of the things we were reviewing were actually not JavaScript APIs or new HTML elements, but they were HTTP headers. And these were things that were being brought to the group from IETF or WhatWG or W3C. Things like these are some of the headers that I reviewed whilst I was on the tag. And a lot of developers still haven't heard of these headers. And many of them still haven't been implemented in any browsers. The other thing that sort of kicked off my interest in headers was that at the last W3C big conference they called TPAC, I was cornered by a certain Steve Souders, and we had breakfast in this restaurant. And he said, Andrew, a few years ago, I wrote this blog post about updating JavaScript that I serve to my users. And I want to be able to update those scripts, but I also don't want browsers to constantly be downloading these scripts from my server. So I want to give them a very long cache time, but I also want to be able to update them whenever I like. And Steve, being the kind of person who likes having his cake and eating it, came up with a hack that enabled him to solve that problem. And he said, Andrew, there must be a better way of doing this now. This was years ago. And I said, well, Steve, you must surely have heard of clear site data. And he says, no, what's that? So I said, well, it's an HTTP header. You just attach it to any response that you send from your origin, and it will clear the browser cache of all resources that are associated with your origin. And he said, wow, I didn't know about that. You should write a blog post. So I did. And I also covered all the other techniques that people have been using in the absence of this technique for clearing objects out of a local browser cache. And in the process of doing this, I realized, to my dismay, that clear site data is actually not implemented in any browser. So this was a little bit less fruitful than I had thought. Fortunately, that was a year ago, and it is now shipped in Chrome. I think it may also be shipping in Firefox as well. So I thought, well, let's widen this and look at some other headers. Let's go to HTTP Archive, which runs web page test on the top 1 million websites every 2 weeks, loads all the resources associated with those sites, all the images and scripts, all of the AJAX requests, and it puts all of the metadata associated with those loads into BigQuery. Anyone can query this archive of data. It's a kind of treasure trove of information about how the web works. And so I wrote some SQL and pulled out all of the response headers that I was seeing across the whole HTTP archive data set. You can look at the frequency with which these headers occur, you can look at the most frequent values, and you can look at patterns of use and how people are actually implementing these. So I did this. I divided these headers into 2 broad groups, the good ones, the best practices, and the bad ones, the headers that still persist even though they should all be long dead, or headers that are best practices but which people are using badly. So let's start with the headers we don't want. And looking down the list of the most popular headers in the archive, The first one that jumps out at me is the first one that I don't recognize. And I didn't think there would be anything in maybe the top 20 HTTP headers that I wouldn't recognize, but I didn't know what P3P was. Could you put up your hand if you've heard of P3P? Okay, so about maybe 5% of the audience. So this jumped out at me for a couple of reasons. It's 10% of responses in the HTTP archive, which seems like a lot for a header I'd never heard of. And more curiously, the most common value for this header is the phrase, "This is not a P3P policy." So, like, is this a P3P policy, or is this not a P3P policy? So I obviously, went on Wikipedia and found out the answer. This is a header that stands for the Platform for Privacy Preferences Project. It is intended as a machine-readable declaration of privacy policy. The idea being that your website would declare via the P3P header what your data collection, retention, and processing policies were, and then user agents could surface that information to end users in a way that is consistent across websites. This actually seems like a really good idea. It was kind of ahead of its time. It was standardized in 2002, and we never really found a use for it. It was implemented only by Microsoft in Internet Explorer, but most importantly, they used it to gate access to a small browser feature which certain developers wanted to use. And you had to have a P3P policy to enable that feature. But it didn't matter what the policy was because there was no UI. So the policy, "This is not a P3P policy," satisfies that check. Obviously, don't do this. It goes without saying. You should not have a P3P policy. This header is dead. But it still persists, and it's one of those aspects of the internet, I guess, that things live on for far longer than they're intended to. But to go from P3P to expires is quite a jump, because everybody in this room, I would think, is familiar with the expires header. This is something that works pretty consistently and interoperably across all browsers, and it simply gives the moment in time at which this resource should expire in cache. It's sent by 80% of responses in the archive. It's one of the most popular HTTP response headers. So why is it always Thursday, the 1st of December, 1994 at 4 p.m. GMT? This is overwhelmingly the most popular value for this header. Anyone want to tell me why? Go on then. It is the example in the specification, yes. So if you wanted a value for your expires header, and you wanted to show that this document has already expired, you just need any date in the past. But to form a date that is a valid HTTP date, uniquely for standard date formats, the HTTP date includes the day of the week. So if I think of some arbitrary date in the past, I would need to know what day of the week that was in order to form a valid HTTP date. And that's one of the reasons why I think it's easier for people just to copy and paste one that already exists. Also, I feel like there's kind of some psychology going on here that people think that yesterday is not far enough in the past. Because often, you see expires with a date in the past. It's always a really long time in the past. Doesn't make any difference, people. Yesterday is fine. But for those people who do use this example, from the spec, they presumably have also read the rest of the spec, so they'll know that the text under the example says, if a response includes a cache control field with a max age directive, a recipient must ignore the expires field. And there's almost no way that they will have missed this because it is written right underneath the example. So if you've read this, then presumably you wouldn't be serving both an expires header and a cache control header with a max age field. Unfortunately, 64% of people do. So over half of the use of the expires header in HTTP archive is redundant. So for sure, use the expires header if you want. It's a perfectly valid way of indicating cache freshness, but don't use it with the cache control header because it's redundant. In fact, often I see things like this. And when I see things like this, I realize that the person who wrote this really, really doesn't want this object to be cached. They very, very strongly don't want this object to be cached because not only are they using an expires header with the date in 1994, and a cache control header containing multiple directives that don't actually exist in a specification. But they're also using a pragma no cache header, which is a request header, not a response header. So if you want something to not be cached, this is fine. No store should be good enough on its own, but it's also worth bearing in mind that edge networks like Fastly, for example, may well take simultaneous requests for the same resource and combine them into a single request to the origin server and then use that response to satisfy multiple incoming requests. That's called request collapsing. You would need to include private to make sure that we don't do that. Okay, now let's talk about XCache, and indeed a whole load of headers that XCache is going to be the representative for today, which are headers that don't exist. Or rather, headers that are not written in any specification anywhere. Despite this, this header is actually present on 13% of the responses from HTTP archive, which is weird, right? Because it feels like everyone has kind of magically agreed to include a header which no one has ever written a definition of. This is actually our fault, because when things flow through CDNs, we typically like to add a little bit of debugging information. So CDNs like Akamai, Fastly, Cloudflare, CloudFront will add headers like XCache to tell you whether the object was a hit or a miss in the edge cache. We probably shouldn't do this because, like all of these other headers, this header is meaningless to the browser. So unless you're a developer, you're our customer, you're the developer of the website, you don't need this information. Likewise, you probably don't need the X powered by or X generator or request ID or varnish ID or anything like this that the browser is not going to take any notice of. So if you're running some kind of front end router in front of your application servers, or you have an edge network where you can write rules that manipulate headers, you might do something like this. This is VCL, so this would be used with varnish proxy. And this would just remove certain headers that you don't need to actually ship to end users. You could get fancy about it. In this particular case, I've gated it based on the presence of an additional request header or a cookie. So if I was the developer of this website, I can opt in to continuing to have this debugging information present. But if I'm an ordinary user whose browser is going to ignore this information anyway, then I don't need it to be there. Now, before I did this research, one of the headers I liked to include on my own sites and which I like to encourage people to use was X-frame options, which has a singular purpose that's really quite useful. It prevents your site being framed by someone else's site, which is a good defense against clickjacking. It's 25% of the web, so this is a really popular technique. And it's almost always set to the words same origin, so it's very easy to implement as well. And the only reason why this is in the bad list is because I discovered there's just a better way of doing it. Rather than shipping a unique header for this, you can actually use a content security policy directive called frame ancestors, which will list the origins that are allowed to frame your site. Now, this is better for two reasons. The first one is that you already have a content security policy, don't you? And the second one is that content security policy is a really well-written spec. It's very precisely defined and therefore has much better interoperability between browsers. So we can expect that the frame ancestors directive of CSP is more likely to be more consistently implemented and give you more consistent behavior than X-frame options. And let's finish up with VIA. So VIA is both a request header and a response header. As a request header, it's really important because it helps to prevent loops between proxies. So when you send a request to a server, it may not be answered from the first server it gets to. It might be forwarded by that server to somewhere else. And when that happens, which is often the case with CDNs or indeed proxies either that live with the origin server or with your organization, a VIA header will be added on the way out. And this enables us to prevent things like this, where, for example, you might have two CDNs that are using each other as backends. And in theory, the request could bounce between them until bad things happen. So to prevent bad things from happening, we have this via request header, and we can detect how many hops a request has been through before it got to us, and indeed whether it went through us previously. Now, as a response header, the via header just tells us which proxies have processed this response, and that's just like any other debugging header, and the browser doesn't really need to know that. So let's move on to the headers which are best practice and which we'd like to see on responses today to improve our security and to improve our performance. So the first one is the content security policy, which obviously all of you already have on your sites, but you are the exceptional minority because it's only 2.9% of the web. And that's an incredibly low number. And even within the sites that do implement content security policy, almost none of them have implemented it in a way that offers them any security whatsoever. The average length of a CSP is almost 600 bytes, and that is by far from the longest that I saw in the archive. So conceptually, CSP is very simple. It just gives you a list of, it gives you the ability to define a list of hosts that your page can load resources from. And this is the example from MDN, which implies that CSP is a very simple thing and very easy for you to put together. And when you do that, you get effectively what amounts to a firewall in the browser. So if some rogue script starts to execute on your page, it limits the damage. It limits its ability to, for example, reach out to its home server and exfiltrate data from your site. This is the longest one that I found in HTTP Archive, or rather, this is a small part of the longest one that I found in HTTP Archive. Which was almost 10K. So if you're writing a content security policy like this, you're probably generating it, I would imagine, unless you're a very patient person and you really like typing the word Google. This is not effective, right? Because apart from anything else, this CSP includes 4 tag manager domains. So, and those tag manager domains could be connected to absolutely anything in the internet. So there's no protection provided by this CSP, and there's no point in serving it, which makes it incredibly ironic that it's so big and it's holding up our response by so much. So have a CSP, think about the CSP, and actually benefit from it. The next one is strict transport security. This one is much more popular, and rightly so, because it's a lot easier to implement. And everyone should be using this if your site is available over TLS, and if it's not, then that should be the very first thing you do when you leave this room. It's very simple, as I said, strict transport security : and then a max age is the simplest way of implementing it. And all it does is it tells the browser that when somebody types your web address and they forget to type the http://, which is everyone all the time, then the browser should connect to you over TLS anyway. So this avoids the redirect, which you would otherwise have to do to redirect users from HTTP to HTTPS, and it avoids opening up a kind of chink in the armor where you could potentially be intercepted and man-in-the-middled. If you're really confident about your TLS, then you can also stick the word preload in here, which will tell the browser that you don't just want to apply this setting to the current user, you want the browser to distribute this information to all other users of the same browser, so that when they connect to your site for the very first time, having never been to your site before, they will also only connect over TLS. Next, we have referral policy. Now, content security policy and strict transport security both relate to security. Referral policy takes a slightly different angle. This is relating to protecting user privacy. And since the very early days of the web, when you click from a link from one page to another, the request that goes to the second server will contain a header which lists the URL that you came from. And this was really useful in the early days of the web before we had client-side analytics for tracking people's movements across sites so we could understand paths and funnels and that kind of thing. But what it also does is it potentially leaks data. If I'm on your search page, and in your search URL you have the query string, the search query that I typed in, and then from your search results page I click a link to an external site, then you're going to tell that external site the search query that I executed on your site, which is a privacy violation. Now, why is only 2.4% of sites in HTTP Archive emitting this header? It seems to me like this should be something that's foremost in our mind, especially since we have things like GDPR, which is something that a lot of businesses are very worried about, and a lot of development teams are spending a lot of time making sure they comply with. I think the reason is because there's nothing about referrers that is actually relevant to GDPR, and so we're spending all of our time thinking about cookies and GDPR and a lot less thinking about referrers. But we should have a referral policy. My favorite option for this header is origin when CrossOrigin, which gives you the full fidelity URL in the referrer header if you are linking internally within your site, and just the host name if you're linking outside. Now, there's a whole set of headers that start with access control. These belong to a standard called CrossOrigin Resource Sharing, or CORS. Unlike the others, which I've mentioned so far, which are restrictive headers, like adding them increases your security, these are permissive headers. Adding them reduces your security. So the most secure way of implementing CORS is to not implement it at all. It has a number of associated headers, access control allow origin being the most common one. And it makes HTTP requests that are cross-origin quite complicated, because the response that comes back will need to include the origin that requested the object. And that makes caching quite complicated, because you might have a server that has an object that is public and you want that to be available to any site that wants to request it. But you can't cache the response because the response needs to include the identity of the site making the request. And this has proved to be quite difficult from a standards perspective. Lots of very controversial GitHub threads. And as a good example of where this can become really hairy, think about cookies. Whether you want to send cookies when you request an object from a foreign origin. Now, the people who created the fetch standard were particularly concerned about this. So they thought, well, if the developer chooses to send cookies with the request, then the server that they send the credentials to needs to acknowledge in its response that it wanted them. And if it doesn't say it wanted them, or it explicitly says that it didn't want them, then the browser will not allow the page to read the response. And what this means is that essentially all URLs are now subject to an additional flag, which is, are you requesting them with or without credentials? So some feel that this kind of dilutes the value of the URL as an identifier for resources on the internet. And I think this is quite an interesting kind of aspect of the evolution of fetch and HTTP. Anyway, if you're interested in best practices in general in relation to security and privacy, I would recommend sites like securityheaders.io, which is nothing to do with me, but it does give you reasonably sound advice about what headers you should be implementing on your site. There's also a tool called Mozilla Observatory that does basically the same thing. You just plug in your address, and it will give you a list of the headers that you probably should add. So moving from security and privacy onto performance, I was going to get there eventually. Client hints. Who's heard of client hints? Okay, lots of people, that's good. So client hints is a new mechanism by which browsers can give you quite granular and detailed information about the user's operating environment, like the width of their screen, the width of the viewport, the pixel density of their screen, whether they've enabled save data mode or not. And these hints enable you to customize the experience for users far better, to save data, to improve performance. And this is how it works. You'll receive a request. The response that you send back will include a response header that says accept CH and lists the hints that you are interested in. So you could, for example, in this case, we're listing all of the current ones, which is device pixel ratio, width, viewport width, and save data, and we're giving that a lifetime. So we're saying that on future requests, we'd like to receive this data, and we'd like to receive it for a day. So on subsequent requests, the browser will now send you some additional request headers, which look like that. I believe they're also now in the process of being prefixed with CH-, but that's kind of very much in flight. The interesting thing about the way client hints work is because you have to ask for them, and you're asking for them in a response, they aren't sent in the first request. So that means that if you want to do something quite big, like let's say you have a text-only version of your site that you want to render for people who have saved data turned on, then you can't do that in the first response because you don't know yet that they want the saved data version of your site. I think this is a shame, and I think the more client hints we add, the more we're incentivizing developers to add a redirect so that the very first response is just a redirect back to the same URL, but this time the browser will send the client hints. And I'm hoping that we won't start to see that pattern, but I fear that we probably will. Especially as there are loads of new client hints being proposed all the time. Mike West from Google proposed these in the Web Incubator community group a few days ago. This is intended to be a replacement for the user agent header. So we replace the user agent header with a series of user agent client hints, which will fix the user agent chaos that's going on, where your user agent header includes basically the name of every single shipping browser except the one that you're using. And in order to be as compatible as possible with various broken regular expressions. So what's the incentive for browser makers not to lie using the new client hints? Will we just kind of have the same problem again and again and again? I don't know, maybe. But I think we've all felt the pain of weird user agent strings for long enough that hopefully we can avoid it by pressing the reset button. I don't know, but I'm optimistic. So let's move on. Link is a header that's been around for a very long time. In fact, in the early days of the web, the link header was intended as a semantic connection between pages. So if you were on a particular page that was, say, a chapter of a book, then the link header would give you the ability to navigate to the next and the previous logical units of content, and would also give you perhaps a link to an index or a contents page. We don't really use the web like that anymore. Some would say that's a shame. But the link header has remained useful for other reasons. And one of the most common reasons we use link today is for the preloading of resources that we know that we're going to use later on in the page. And we've seen this technique already being talked about today. So most commonly, preload is used for fonts, as Zach demonstrated earlier on today. And here's a good example of loading a font and a style sheet using the Linkrel Preload. This is a screenshot from an Adi Osmani blog post. Adi Osmani is a Google developer advocate. He did some work with Tinder to add Linkrel Preload and showed that they could reduce the amount of time before their JavaScript started loading from about 800 milliseconds down to about 220-ish. By just telling the browser ahead of time that that JavaScript was going to be needed. Now, the problem with this that remains, even though this is really good and this gets us a big performance improvement, if you're the kind of person who is not satisfied until you've managed to eke out every single millisecond, then it's worth bearing in mind that you can't actually get these headers down the wire until on the server you've decided that this is going to be a 200 OK or a 404 not found or something like that. You need to decide what the HTTP status code of the response is going to be. And that's a problem because sometimes on the server we need to do quite a lot of work before we know what that status code is. So if we look at a full waterfall from the moment that I type in a URL and press enter, there's some time that we can't do anything about, the DNS lookup, the TCP TLS connection, although those are being speeded up through other means. But then there's this whole section here where we're just waiting for the server to decide what the response is going to be. And then once we start receiving the response, we can then kick into high gear and parallelize the loading of loads and loads of stuff. And that's where everyone is starting to optimize, like, what order do you load things in, and what's the loading priority, and all this kind of thing. But during this period, nothing is happening at all. We're just waiting for the server to respond to one single HTTP request. So at Fastly, along with some other people in the industry, we're working on a new status code called 103. The description of this will be early hints. And the idea is that you will be able to send 2 status codes in an HTTP response. The first one, 103 early hints, allows you to send headers, but no body. You then still need to send a second status code once you've decided what it's going to be. And then you tend to repeat the same headers that you included in your early hints response. So what this enables is for us to respond to requests as soon as we receive them, with an early hints response that includes some kind of link preload or maybe some security headers or whatever we want to get down to the browser ahead of the actual response. The browser can then get working on preloading things like the fonts and the style sheets before we've decided what the real HTTP status is. So this is really cool because it's using time in the waterfall that's currently vastly underutilized, but it is very hard to ship because it's going to require changes to not just browsers but also web servers and also CDNs and middle boxes. Another performance header I really like is server timing, which allows the exposure of your server timing data with the same kind of granularity that you can see the data that you can already access via the waterfall. So we're familiar already with those waterfall charts that have been in virtually every presentation you've seen today, but typically the thinking time on the server, that time period that we're trying to optimize with early hints, is usually represented as a single bar. You know, something is happening on the server, we don't know what it is. Server timing allows us to expose that period of time with greater granularity, because we can say things like, we spent 53 milliseconds in the database, we spent 47 milliseconds in the app, and we can also attach custom metadata, like we can say, this request hit the Atlanta data center. And if these headers are present on a response, then some browsers, notably Chrome, which is the only one that's implemented a UI so far, can render that information in an interesting way. So if you look at DevTools in Chrome and you go to a site that has server timing headers, then you see the waiting section here, which is just waiting for the server to send something. But that is then broken out into all of the different things that the server is doing during that time. This is one of those things that you probably only want to return when you know that the end user is a developer, but is super useful if you are, in fact, the developer. And it has a JavaScript API. And this I find particularly interesting because you can dive into these numbers on the client side. You can beacon them to some analytics service if you want. You can use tools like SpeedCurve to monitor your resource timing, and also you can report your custom server timing and user timing metrics as well. The other interesting thing about this is it's the first time, I think, that we've had a JavaScript API into a header dictionary. And that gives me some ideas. What if we just use the server timing header to communicate any kind of key value data to the browser, and then just write a little bit of JavaScript to extract it into an object? This would be quite useful. If you wanted to attach additional metadata to your responses and you've already generated them, or maybe you're pulling a response out of cache, so you already have a fixed frozen object in cache, and you want to annotate it with some additional data before you return it to the browser, this could be an interesting way of doing that. Things like the number of articles you have remaining on your paywall, for example. This technique currently only works in Chrome. I'm intrigued to know whether this is something that should be possible, or whether it shouldn't, but it is possible. So I'm going to finish up with a couple of very, very new things. Feature policy is a header that is absurdly powerful and which hopefully will really change the way that we look at the web platform over the next few years. The idea of feature policy is it starts to, for the first time, allow us to reduce the size of the web platform. So every time we add a new API, we're adding new capabilities, we're adding new hooks, we're adding new vectors for attack, and in some cases, we're adding new capabilities for bad practices. Like video autoplay, for example. Video autoplay becomes possible, and everybody starts autoplaying videos. Then we realize, actually video autoplay was a really bad idea. We can't unship it though, because that would be not backwards compatible. So what if there were a way you could specify in a response header that you are not going to use video autoplay? So the browser can feel free to just turn that feature off completely. And if you were to try and use it, it just wouldn't work. And this would be a really good way for you to communicate best practices to, say, search crawlers. You could also self-police your development policies, make sure you didn't have to carefully review everything in light of policies you've written in a wiki or something. And in the future, we could really go to town on this with policies like document.write, which we could turn off using a feature policy. So if you have trouble with bad acting third parties on your site, for example, still using obsolete web APIs that are degrading your performance, then potentially with a feature policy, you could just turn that feature off completely. And sites that you wrote like 10 years ago, before dozens of new web APIs appeared, you could turn off all of those new web APIs that you know that you're not using on that site because you didn't know about them at the time. And that is going to reduce the attack surface of your site and make it less vulnerable. So I'm really excited about feature policy. I think everyone should be really excited about feature policy. Another reason I think you should be excited about feature policy is that it's one of the things which the Google AMP team have pointed to as a necessary prerequisite to moving AMP onto a standards footing. So AMP is currently a very proprietary set of technologies, especially in terms of its integration into search. And with feature policy and a load of other things, we can hopefully be able to move away from that and move AMP back into the web platform. And the final thing is origin policy. And I hate to end on a slightly disappointed note, but this is something I was really excited about, and it's kind of on ice at the moment. But we talked about how HTTP requests and responses started out looking like this, and how today they look a little bit more like this. And I haven't really given you any reason to think that they're getting any smaller. In fact, they are probably going to continue to get larger. But one thing that we have discovered today is that a lot of these headers aren't specific to one response. So things like strict transport security, for example, you're going to set that on every single response, and it's not specific to that one response. So these kind of headers, these sort of origin-wide headers, would be better off somewhere else, like, for example, in a JSON file, where you could specify origin-wide policies, like your content security policy, like your referral policy, like whether you have strict transport security enabled. And then you could just reference that origin policy in your response rather than having to repeat these headers every time. Now, I don't think this particular standard is going anywhere at the moment, but I was quite excited about it when it appeared. One argument as to why we don't need this, incidentally, is the new header compression in H2. So if header compression works in HTTP2, in theory, if you send the same set of headers repeatedly, they all disappear into the compression dictionary, and it doesn't really matter. But from a developer perspective, I feel like I kind of just lose the plot when I look at a list of 25 headers, and only 3 of them are actually changing on every response. And I would much prefer to put that more formulaic kind of boilerplate stuff somewhere else. So to recap, I've talked about lots of headers. Some of them are things that you should be implementing if you don't have them already. Some of them are things which, maybe if they apply to you, you should use them. Some of them you should keep an eye on because they're not shipping yet, but when they do, they're going to be really useful. And some are things which maybe are past their prime and you should look to remove them from your site if you still have them. And and if you're interested in reading more about this, I've written a couple of blog posts that include all of the headers I've talked about today. It starts with this one, and then there's a link to the part 2. And that's all I have. Thank you very much.
Thanks, Stu. Yeah, if you mind. So the header adoption for a lot of those is a lot lower than obviously you'd like to see. Like,
Yep.
how much of that do you attribute to the fact that, as you were kind of discussing with me before, like headers sort of live in that in-between space a little bit. Like it's, kind of in between the front-end developer and the back-end developer.
I think certainly the lack of communication about these things is an important factor. People learn a lot about optimizing JavaScript, and they learn a lot about individual things like Linkrel Preload, for example, has much more adoption than some of these other things because it comes up in conjunction with loads of other stuff about performance. But I think there is a sort of lack generally of communication about header metadata. And I think that's actually also responsible for why we have a lot of cruft that's still there, because there isn't enough talk about just that area in general and how we can optimize and remove unnecessary stuff. So I think people copy examples they've seen and Stack Overflow answers, and the stuff that we don't need anymore just keeps getting perpetuated. So
there's a general like awareness and empowerment kind of thing.
Yeah, I think so.
There, and then ties into client hints, right? Like, client hints are one of those things that, like, depending on who you are, you're either really, really excited about it, or you were kind of like, man, we've got this other stuff for responsive image standards. But that sort of that header side, there's more of the server side sort of thing, sending the header down can be extremely powerful. But I know one of the other considerations around client hints that has caused some hesitation, right, is like the ability to profile users potentially, if like depending on the values. Is there anything being done to sort of handle that? What do you think about that? Is that like a concern?
Yeah, so this is a really interesting point. The client hints don't require user consent. So although they aren't sent automatically and you have to request them, the user is not involved in that process. So the browser will then just send all the hints that it's asked for. One of the arguments in favor of that pattern is that at least then the browser is aware that that domain is interested in that data, versus just sending it to all servers and not knowing which sites are using it and which are not. I have some sympathy with that point of view. I just think that we're gonna find that a lot of sites are requesting that data.
Sure. Yeah. I can see that. I think that people have talked about like the privacy implications of a whole bunch of stuff, and like that gets into like how granular do you get with the control versus like having some sort of an umbrella policy that you apply to a given site or something like that.
And people are already sick of permissions prompts, right? I think I don't think anyone would really be in favor of us advocating, a modal dialog that comes up saying, "Are you willing to share the width of your screen with this server?" Sure. I mean,
that seems a little precise. So one of the things that somebody was asking was, so some of the headers that you had talked about, like, adopting content security policy, the P3P stuff, if somebody is supporting IE11 today, right, that means that content security policy, which is, I think, supported technically with like an X hyphen.
It is, yeah.
But I think that P3P is still needed to be able to handle something with the way that it communicates with cookies inside of iframes and all that kind of stuff. Is there a downside to sending those sort of legacy headers along still?
So depending on what point you are doing your kind of server-side caching, then potentially you could be smart about this and send the headers only to user agents that needed those. And ideally, there are just one or two very small exceptions. But yeah, in general, if you need it for one, then send it to all. There's
probably okay.
There's a trade-off to be made, and it's unlikely that the optimal point is to send a customized response to every browser. That seems like it's going to be a waste of your time.
Yeah. And just to clarify, like all the values for these different headers, those are case insensitive, or is there situations where you do have to be aware of the case?
So headers are case insensitive for the key, and they are case sensitive for the value, but individual headers will specify the format for their values. So in some cases, the value might be case insensitive, and in some cases, it will be case sensitive.
So it really just depends on the header. Yeah.
It does depend on the spec, but I think in most cases, the values are typically case insensitive. Like cache control, for example, you can write max age in uppercase or lowercase if you want.
Okay.
My favorite example of an inconsistency in the way that headers are specified, and there are loads of them, is the referrer header, which is kind of famously misspelled and only has one R. That persists on the web today. Like there is no alias with two R's, and yet referral policy is correctly spelled and isn't alias to one R. So you have to correctly spell referral policy and incorrectly spell referrer.
That is delightful. That's great. No, I have a lot of respect for the folks who come up with the specifications and the standards, but every once in a while you get fun things like that. So yeah that's good.
I'm sure that lots of people had a long conversation about that, and I have not done any research into it. So I don't blame anyone for that decision. I'm sure it makes sense when you look at it in some way.
And in those situations, are there any situations where a given header would be interpreted differently if it was, so let's say the header says, it is case sensitive for a given header. Is there any situation that you're aware of where like a browser interprets it differently based on that? Like avoids, like maybe didn't listen to the spec, didn't behave quite well enough, and is looking for lowercase or uppercase or something case sensitive?
Not that I'm aware of. I mean, I haven't really done any research into that. I think a good example would be cookies, I guess. Cookies are developer defined values, so they're case sensitive. And in most cases, I imagine bad things would happen if you interpreted them with the wrong case.
Cool. Well, thank you very much, sir.
You're welcome.